Hello class, I hope the test yesterday wasn't too torturous, but just think of me while you guys are doing this in a nice sunny and warm New Orleans. Okay, let's get started. Parallel lines, as many of you may remember or have started to figure out, the definition of parallel lines would be two lines with equal slopes. So what does parallel mean? Well, it means a few things. It means that if I draw a line and I draw another line next to it, they will never cross. This means they'll never intersect, which means that there's no common points between the two of them. It also implies that if I were to draw a vertical axis through that and a horizontal, and just kind of have this be an example, parallel lines have different y-intercepts. Because if they were parallel and they'd have the same y-intercept, that would mean that they were the same line, which is not true. Anyway, let's look at the first question here. Write an equation in slope-intercept form of the line that passes through this point and is parallel to the graph of this one. So we want a new equation. Well, let's take this one, and like we do for others, let's solve it for y. So I'm going to have 3y. If I subtract 5x from both sides, I get negative 5x plus 9. Divide both sides by 3. And I have y is equal to negative 5/3 x plus 3. If I graph this line, we go y-intercept of 0, 3. Negative 5/3 means up 5, but then left 3. Or down 5, right 3. And I have enough room here to do another down 5, right 3. Connect. Okay, that's the line. That's this line here. But now I'm going to want to do something with this point 6, negative 3. So let me switch colors here. 6, negative 3 would be right 6, down 3, and here. Well, I can see that if this is 6, negative 3, and I want to have them be parallel, I've got to use the same slope. So I have enough room for up 5, left 3. I could go down 5, right 3. Then I have enough for up 5 and left 3 again. And as I can kind of see here, connect these probably with a straight edge a little better than I am, and those will never, ever, 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 ever cross. So that's the basis behind parallel lines. I think I messed up my up 5, right 3, so you got to sit with me while I fix this, because I'm a little picky about this. There we go. Up 5, left 3. Ooh, that looks so much better. Okay. There we go. If I look at this line, though, and I take this, let's go back from that line to the equation, well, I know that it's going to be y is equal to negative 5/3 x, but I have a different y-intercept now. Just by plotting this, I can see that I'm now up 7, so I actually put a plus 7, and that is because my y-intercept is now 0, 7. So, how could we have figured that out a little bit easier than graphing it? Because graphing it's okay. Well, let's go to the next one, and we're going to try to do this equation first and then graph second. Up here we did graph first and then equation second. So I'm going to take this equation, I'm going to solve it for y. Negative 2y equals negative 3x plus 7. Divide both sides by negative 2. And I have y is equal to 3/2 x minus 7/2. Now, that's lovely. That's nice. But the only thing I really care about is the slope. So I'm going to steal the slope from this line, and I'm going to say the slope is 3/2. And I'm going to ignore the rest of it. Then, like we do for any time that we want to figure out the equation of a line, we're going to use point-slope form. Yes, Gino, I picked pink now. So I'm going to take this and I'm going to take this, and I'm going to merge them and say y minus 1 is equal to, the slope is 3/2, x minus a negative 3. Okay, let's go back up and confirm what we want. Okay, slope-intercept form. So we got to distribute the 3/2. 3/2 x plus 9/2, not fourths. Add 1 to both sides, and I get y is equal to 3/2 x. This is 5.5. 5.5 is perfectly acceptable in the world of stuff, so let's go up. Put a point at 5.5. My slope says it's up 3 right 2, and down 3 left 2. Okay. Now this is one of those cases where if I connect these, I can see that it's actually passing through this point. And if I go to this equation and plug 1 in, like do a little t-charting, plug 1 in, I get 3/2 plus 11/2, 14/2, or 7. 1/7 is an ordered pair of that line. That's this point right here. All I'm doing is just checking that, okay, now we got it at crosshair points. Those are good. Let's go down 3, left 2, down 3, left 2. This way we're doing our slope from actual crosshair points. We can do it a little bit faster. And look at all these points that we just have to connect. Good line. That is the pink line. If I was graphing the other line, you could see it, but it would not go through the same points because it's parallel. Okay, I'd say are there any questions, but obviously I'm not here to answer them, so sorry. Okay, definition of perpendicular lines. Perpendicular lines are lines that cross at right angles. So think of any of the non-roundabout intersections that happen on the north side of Indianapolis. Any of these that occur in a grid are perpendicular. In fact, every single time you see a little perpendicular crossing here on a grid, that's right angles. Okay. Write an equation in slope-intercept form of a line that passes through the given point and is perpendicular to the graph of each equation. Well, let's go back up to this definition. If two lines are perpendicular, the product of their slopes is -1. Okay. That means that if I have a slope of 2, my other slope has to be -1/2. Because that's the only number that I can multiply by 2 to get the product equal to 1. That means if I say, hey buddy, you got a slope of 3/2, what's the perpendicular slope to that? Well, the perpendicular slope would have to be -2/3, because those are the only two numbers, or that's the only number that can multiply by 3/2 to give you -1. Okay, here's another example. Let's say I have the number 5. What am I going to multiply by 5 to get 1, or -1? Well, if I multiply by 1/5, I get 1. If I multiply by -1/5, then I get -1. Oh, I know, we're going to do one more. Let's do -7/10. The number that I would multiply by -7/10 to get -1 is +10/7. That will give me -1. So these slopes are all perpendicular to each other. And if I go down to number 3 and I look at what it's asking, it says, hey, here's a line, but we don't care about that line. We want a different line. We want the line that is perpendicular to that. Furthermore, I want the line that is perpendicular to that crosses through the point 2, -3. I'm even going to graph 2, -3, so I don't lose sight of the fact that this is the point I want to cross through. Okay, well, like we did in the previous one, we're going to steal a slope from this line. So I'm going to say 5y, subtract 2x from both sides, and I get -2x minus 10. Divide both sides by 5, and I get y is equal to -2/5 x minus 2. That's nice. The slope is -2/5. But I don't want that slope. With parallel lines, we did. With perpendicular lines, I now want to say,
m perpendicular, see the little subscript there, equals, okay, if it's 2/5, let's go back up and look at these 1,000 examples we just did. If it's 2/5, then the perpendicular one would have to be 5/2. 5/2 is the only number that I would multiply by 2/5 to get, or negative 2/5 to get a product of -1. Sometimes people look at this and say, this is really the opposite. Opposite meaning if it's positive it's negative, it's negative then it's positive. Opposite reciprocal. Reciprocals are those things we do when we flip fractions. So opposite reciprocal is positive 5/2. I'm going to take positive 5/2. Then I'm going to marry it to this point, to -3. You are going to take that fifth thing that I wanted you to remember, and remember that y minus the -3 equals positive 5/2 x minus 2. Oh yes, point slope form. Okay, distribute the 5/2, and I get 5/2 x minus 5. Subtract 3, and I get y is equal to 5/2 x minus 0. Okay, this is what we're going to graph. That is also your answer. If I graph this, I go down 8.
Then, nope, that's not 8, that's 7. This is 8. See, it wasn't going to pass through that point we just did. But now it will. If I go up 5, right 2, holy gosh, it passes through that point. Okay, then here, and now we cross and make our beautifully shaped line. That yours would be better because you would use a straight edge. And I'm going to say I can't because, you know, the whole drawing tools thing. Okay, there's our line. Let's do another one.
Solve for y. Divide by -2. Please tell me you put -3/2. Not that it matters because we're going to take this 3. I'm going to say the perpendicular slope is going to be -1/3. I'm going to take this, take the point. Y minus 1 is equal to -1/3 x minus 4. Distribute the -1/3. I get -1/3 x plus 4 over 3. Add 1 to both sides. Y equals -1/3 x. When you add 1 to 4/3, you're adding 3/3. So you get 7/3. 7/3 is not a great y-intercept. But if I were to do a t-chart and plug 1 in for x, I get -1/3 plus 7/3, or 6/3. 2. 1, 2 is an excellent starting point. If I look at my slope, it's down 1, right 3, up 1, left 3. Let's finish putting all of those through the grid, and then connect.
Okay, keep going.
Determine whether the graphs are parallel, perpendicular, or neither. Well, the best way to do this is to set them all equal to y. This is set equal to y, but this second one is not. Y is equal to -2x plus 23. They have the same slope. They are parallel. The next two, I have -5 and 5.
They're both set equal to y. These are opposites, but they are not reciprocals. They're not opposite reciprocals. That's neither.
Here I have y is equal to, let's write that with fractions. Y is equal to 3/5 x plus 7. 0.6 is 6/10 or 3/5. Here I have y is equal to -5/3 x plus 10. If I divide both sides by 10. So there's one, there's the other. Positive 3/5, -5/3. Those are opposite reciprocals. Those are perpendicular.
Then here I've got y equals -11. Ooh, you know there's something special about that one. We'll box that as our thing. And then I have, if I subtract y from both sides, that goes away, and I have x equals 7. Ooh. This is a horizontal line. That is the third or fourth thing I asked you to remember. If that was the third, then this one's the fourth. X equals 7 is a vertical line. I don't care about slopes right now. You guys should all know that a horizontal line and a vertical line are perpendicular. So, last set.
An equation that having the following properties. Passes through negative 5, 3, and is perpendicular to the x-axis. Perpendicular to the x-axis, let's sketch this thing. Here's the x-axis.
Perpendicular means it's doing something like this. That is a vertical line. All vertical lines have x equals equations. So, x equals, oh, look, there's negative 5. You're done. It's parallel to the graph. Y is equal to 5/4 x minus 3, passes through the origin. Not sure why there's a 1 there. Okay, if it passes through the origin, well, that's 0, 0. Parallel to the graph, y is equal to 5/4 x minus 3 means that slope is 5/4. So, let's just do slope-intercept form. Y is equal to 5/4 x plus 0. There you go. How did I know I could do slope-intercept form? Well, if it passes through the origin, this is my y-intercept because x is 0. It's also your x-intercept because if it passes through the origin, they're kind of the same thing. Okay, now continue up, or down, or whatever you call it. Has an x-intercept of 3. That's an ordered pair 3, 0. Pick my comma back. And is perpendicular to the graph that we need to solve for y. Divide by negative 3, and I have 5/3 x minus 2/3. Carry this over. Let's change it to a perpendicular slope. M perpendicular is equal to negative 3/5. I want it to pass through 3, 0. That is not a y-intercept, so we have to use point slope form. Y minus 0 is equal to negative 3/5 x minus 3. Distribute, and I have y is equal to negative 3/5 x plus 9/5. And that's slope-intercept form. Lastly, it has a y-intercept of negative 6. Ooh, that's always good. We can go straight into slope-intercept form. It's parallel to a graph that I need to solve for y. Again, okay, negative x plus 3, or negative 3y is equal to negative x plus 8. Divide by negative 3, and I have 1/3 x minus 8/3. Well, what I care about that is its slope, but I'm going to keep it because it's parallel and not perpendicular. Now we're going to form this into a nice little line. But I can pull this straight into slope-intercept form because I have the y-intercept, minus 6. Done. Let us remember to thank the good people at YouTube for allowing me to have a video longer than 15 minutes.